Hi everyone, welcome to the second part of our 8.1 notes, and we're just going to finish up here looking at how to graph a system if we're given two lines, two equations, and we're trying to solve the system. So we're looking for the point of intersection. Graphing and solving a system is quite straightforward. In fact, you already know how to graph a line. I'm going to show you a fast way to graph a linear equation. Okay, so method one is the fast method, and I really encourage you to try this method and use it because this is a great one to use. So to graph a line, you can use the slope and the y-intercept in order to graph your line. So what we do is we start at the y-intercept because we know that's a point on the graph. So whatever our b value is, we can start there. And then we use the slope. Remember that your slope tells you your rise over your run. So we use that slope to find the next point on the line and the next point and the next point. And once we get 3 or 4 points, we can connect those points with a line. And there's our graph, our line. So this is a fast method to graph a line. And all we're going to do here is graph two different lines and look for where they cross. So it says graph and solve the system of linear inequations. So as soon as I see graph, I know I have to graph them. Solving means I'm going to find the point of intersection. I'm looking for the solution. Okay, and I have two lines, line 1 and line 2. So I'm going to go ahead and call 2x plus y equals 2. I'm going to call that line 1. Okay, and I'm going to call the second equation y equals x minus 7. I'm going to call that line 2. So we're going to go ahead and graph both of those. So step 1, let's graph line 1. Okay, so this is line 1. 2x plus y equals 2. I want to get line 1 into slope-intercept form. So I'm going to rearrange. Okay, I want it in y equals mx plus b form so that I can see clearly the slope and I can see the y-intercept. So we're going to go ahead and do that. So I have 2x plus y equals 2. All I need to do is move that 2x over to the other side because it's on the wrong side. So what I'm going to get is y is equal to, when I move that 2x to the other side, I have to subtract it from both sides. I have to subtract it from the left and also from the right, or I have to move it over and change its sign. Okay, if we use the export method. So I get y equals negative 2x plus 2, because I still have a 2 over there. So now I know that my slope is right here. Okay, m is equal to negative 2 over 1, and that is my rise over my run. Okay, a rise of negative 2 tells me to go down 2 over 1. Okay, let's write that down. That means a negative rise tells you to go down 2, okay, and then over 1. So we're kind of working backwards here. Instead of finding our rise over run from a line, we're actually going to use the rise over run to plot data points. The last number in my equation, this 2, is my y-intercept. So b equals 2. So that's the point, 0 for x, 2 for y. In other words, my line crosses my y-axis at 2. So what we're going to do is we're going to start at 2. So we're going to go ahead on the y-axis and go 1, 2. Okay, there's my b value. b equals 2. And then I'm going to use my rise and my run to find the next point on the line. So from the y-intercept of 2, I'm going to go down 2 over 1. I'm going to use my slope. So I'm going to go down 2 over 1 and put a data point. Down 2 over 1 and put another data point. Okay, down 2 and over 1 and another data point. And you can do this as many times as you like, okay, until you get enough points for a straight line. And then you're going to go ahead and get your ruler out in a nice straight line to the best of your ability, you're going to connect all those points. And sorry, my line is not very straight, but with your ruler, you can do it a little bit better. There's line 1. Okay. Then, and let's go ahead and write the equation for line 1. Line 1 had the equation y equals negative 2x plus 2 once I rearranged it. The next thing I'm going to do is I'm going to plot my other line, which is line 2, y equals x minus 7. Okay, so now I'm doing step 2. It's already in y equals mx plus b form, so that's great. So I don't have to rearrange this one. So what I'm going to do is I'm simply going to identify the slope and the y-intercept. Okay, so this time when I look at my line, well, what is the slope? The slope is just 1 because that's the number in front of x. There's my value for m. So my slope is going to be 1. And I can always write any number that is just an integer like 1 over 1 as a fraction. So that tells me my slope is 1 over 1. That's equal to my rise over my run. So a rise of 1 tells me to go up 1, and a run of 1 tells me to go over 1. So a positive slope tells me I'm going up, or increasing slope, and a 1 over 1 tells me to go up 1 and over 1. Finally, my y-intercept here is equal to negative 7, so b equals negative 7, which is the point 0, negative 7. So in other words, line 2 crosses my y-axis at negative 7 on the y-axis. So let's go ahead and plot it. So I start with my y-intercept because that's the only point I know. And it's way down here at negative 7. So there's b. Okay, that's a point on my line. From there I can use the slope to give me some more points. So starting at negative 7, I'm going to go up 1 over 1. I'm going to use my slope. Up 1 over 1, put a data point. Up 1 over 1. Up 1 over 1. Oh, there's the solution. Up 1 over 1. Let's keep going. Up 1 over 1. And you can do as many of these as you like until you feel confident that you can connect them with a nice straight line. You get out your ruler, okay, and you're going to connect those. I'm going to put an arrow ahead on each side because this line just goes on and on in either direction. There's no restrictions or limits on my line. Okay, so now that I've graphed both lines, and let's go ahead and just call this green line line 2, and I'll write the equation for it. This is just a good habit. Y equals x minus 7. Just keep track of what line that was. Okay, so my solution is the point where they intersect. That's this point right here. Let's see what that point of intersection is. Well, if I come up to the x-axis, that's at negative 3. And if I come over to the y-axis, it's at negative 4. So this is the point, positive 3, not negative 3. Positive 3 for x, negative 4 for y. Okay, so there's my solution. 3, negative 4, which means x equals 3, y equals negative 4. That's the point of intersection. There's my solution. This is a nice, quick, easy way to graph a line. Start with your b value and use the slope to get your next data points. Let me just show you that that's not the only method. So there are other methods you can use to graph a line. You don't have to use that quick slope-intercept method. Another method is a simple one that I have here is you could find the y-intercept, which you can already tell from your equation. You can also find the x-intercept, which is the point where that same line crosses the x-axis. So that's when y is equal to 0. And then you can connect those 2 points. That's also a really fast method. I'm going to actually introduce a method 3 to you because this is a method you already know. So I'm going to say to you, I encourage you to either use the fast method or method 3, which is to use a table of values, because you already know how to do this. So let's keep things simple. If you wanted to graph any line or to graph any function, you can always come up with a table of values. So you pick some values for x, solve for y, and simply graph it. Okay, so if you wanted to here, we're going to get the exact same answer, but if we wanted to use a table of values, again, we could go ahead and say, well, line 1 has an equation 2x plus y equals 2. Again, I'd like to get that into y equals mx plus b form. So I'm going to move that 2x over. So I get y equals negative 2x plus 2. And then I could make a table of values. So x and y. And I'm just going to choose some values for x. Remember how we do a table of values. So we might go negative 1, 0, 1, and 2. And then you're simply going to plug in x equals negative 1 into your equation and solve for y. So for the first one here, I'll just do the first one. If x equals negative 1, we'll put in a negative 1 for x and leave the rest of the equation as it is and solve for y. So we would get negative 2 times negative 1, which is positive 2, plus 2, which is 4. Okay, then we put a 0 in for x for the next point, and we'd get 2 for y, okay, because the negative 2x would cancel. If I put in a 1 for x, I get negative 2 plus 2, which is 0. If I put in a 2 for x, I get negative 4 plus 2, which is negative 2. So right away, there I go. There's 4 points on my line. I can plot them now. So negative 1 for x and 4 for y is right here. Okay, the next point is 0 for x, 2 for y. So that's right there. Okay, 1 for x, 0 for y. And finally, 2, negative 2 is 2 for x and down 2 for y. There's enough right there. I could go ahead and use my ruler. It is important to use a ruler here. Okay, and there's my line 1. Okay, and I could do the exact same thing, a table of values for line 2. So again, you just pick some points for x and you solve for y. So we often pick negative 1, 0, 1, 2, 4 or 5 different values for x, and again, plug them in. So I'm plugging them into my equation. So if x equals negative 1, and I have to subtract 7, I get negative 1 minus 7 is negative 8. Okay, if I put in a 0 for x, I get negative 7. If I put in a 1 for x, I get negative 6. And if I put in a 2 for x, I get negative 5. So again, I go ahead and figure out some points using my table of values, and I plot them. So the point negative 1, negative 8 means I'm back 1 and I'm down 8. Okay, and then I have the point 0, negative 7, which is 0 for x, negative 7 for y. 1, negative 6, that's 1 for x, negative 6 for y. Okay, 2 for x, negative 5. And again, you could do a couple of more points there. And again, you're connecting them with your ruler, a nice straight line. Okay, my line's not very straight, so I might not quite get the right point of intersection here. If I'd used a ruler, I should have gotten the right point of intersection. So I'm a little bit off. It should be right there. Okay, but if you use a ruler, you'll get the right answer here. Okay, and so again, we should have the exact same point here, 3, negative 4. So if I come up 3, and there's my solution. Okay, the point 3, negative 4. So there's more than one method for you to go ahead and graph that line. So our answer here, no matter how we do it, how we choose to graph, will be the point of intersection. So that's going to be 3, negative 4. And if I wanted to verify these solutions, I would plug that point in to both equations. So I would plug in the point 3, x equals 3, y equals negative 4. I'd have to plug that into line 1, which had the equation y is equal to negative 2x plus 2. Okay, and I'd also have to plug it into line 2, and that's x minus 7. and sorry, y is equal to x minus 7, and you're looking for two equal statements, I'm going to have to pause this right now just because I'm going to run over my time limit. But I'd like you to try verifying it yourself and make sure that you get the correct answer. Okay, thanks for joining me. Bye for now.